So like usual, when we have a new kind of function, we plot some points, make a table of values, plot some points, just to see what the shape is. We did this one, this from the book, it's example 1 from this section 8.1. And this is the function that we're going to graph. Y equals 2 to the x. Now, remember that in the example, in the formula, it was a times b to the x. But you don't see an a because what does a equal? It's 1, right? If you didn't see another number in front multiplying, it's because that number is 1. Okay, and then it's 2 raised to the x power. Should have said this before, but this 2, whatever is being raised to the x power, that's the base, right? That's called the base of the exponential. Okay, so make a table of values. And this is from the textbook, but where did they get the values? X equals -3, -2, -1, all the way to 3. Say again? Koki? You just pick a member. X is the independent variable. The thing that's on the right-hand side, that's inside some kind of an expression, that's the thing that you get to pick and plug in, and then you calculate what's on the other side that it's solved for. So this is always the independent variable you get to pick, and then you calculate the dependent variable. And so they picked all these numbers. That's probably more than I would pick, but it's okay. That's where they came from. We don't dwell on where they came from. And so what are they doing? In each case, they're plugging in the x there, and they're calculating the y value. So that gives us a whole bunch of the 7 different points that we can graph here. Notice that when x is -3, that's 2 to the -3, which by the properties of exponents is 1 over 2 to the +3, or 1/8. And that's 0.125. That's this point right there. Okay, so what do you notice about this graph? Is it increasing or decreasing? Or from left to right, you would say that it's increasing, right? In an exponential function, if the b is greater than 1, it's called exponential growth, right? And it'll be increasing from left to right. So b is greater than 1. That is called exponential growth. Okay. We could see what goes on here. When I have -3, I get 0.125. If I put in -4, it would be 1 over 16. It would be even smaller, right? If I make these numbers get less, get bigger in a negative direction, that fraction gets smaller and smaller and smaller. Is there anything that I could plug in here that would make y equal 0? Right? No. What would happen if I put in if you put in a 0, you get 2 to the 0, which is 1. Right? So, and if I put in really, really big negative numbers, the fraction gets smaller and smaller and smaller, but it never equals 0. So that means this graph right here, it's never going to touch the x-axis. So we would say that the x-axis is an asymptote. And usually on the graph, we sketch it as some kind of a dashed line, and then you name it y equals 0, because that's how you say a horizontal line. Y equals a constant. In this case, the constant is 0. Okay. This line will get infinitely close to y equals 0, but it will never equal 0. So there'll always be some distance in between that line and the x-axis. Now, remember, we have to keep emphasizing domain and range. What does domain usually refer to? X values, right? And when you have an infinite number of points making up a continuous line like this, then you can't list all the x values. Instead, we're going to give a range of values. This arrow is going infinitely to the left. That arrow is going infinitely up and to the right. So you would say that the domain is all real numbers. All real, because this is going to keep going infinitely to the right. It's infinitely to the left. So the domain is all reals. Okay, now what do we usually refer to when we say the range of a function? The y values, okay? And in this case, is the range all real numbers? Does it go infinitely up and infinitely down? Yeah, I mean, it gets infinitely close to this line, but it's never less than y equals 0. So you're going to have to say that the range is y greater than 0, not or equal to, because it never touches y equals 0. So that's the range. The last thing that we look at are intercepts. Now, if it never touches the x-axis, there is no x-intercept, right? The y-intercept is right there, okay? And that's the value you get when you plug in x equals 0. That's this number right here. Right? This is y-intercept. Y-int. So those are all the details of this function.